We're now going to learn how to use this thing called the quadratic formula. And the quadratic formula is just the equation x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now, in order to actually use it, we need to know what a, b, and c actually are. And in terms of the standard form of our equation, if we have a quadratic equation, it is normally written in standard form as ax squared plus bx plus c equals 0. So we have an equals 0 on the one side. The coefficient of the x squared is our a value. The coefficient of the x is our b, and the constant term, or the y-intercept, if it was a quadratic function, is our c value. So that will help us be able to apply this quadratic formula. Now my example A could be solved just by isolating. We did that in our last unit, or last session. We could add 8 to both sides, and we would have x squared equals 8. And then to undo the square, we would square root both sides. So x would equal plus or minus the square root of 8. So that really gives us that x is equal to, I'm just going to punch that into my calculator, about 2.83, so approximately equal to 2.83, or x could be equal to negative, approximately equal to negative 2.83. Now that one is a simple one just to go ahead and solve by isolating, but I want to show you that it actually will work with the quadratic formula as well. Now in terms of our coefficients, the coefficient of our x squared is just a 1, so my value of a is equal to 1. I don't have a b term at all, or like an x term at all, so my b value is actually equal to 0. So if one of the things is missing, its coefficient would be a 0, and my constant term, the c, is negative 8. So if I take my quadratic formula and substitute my values in, I'm going to get x equals negative b, or negative 0, plus or minus the square root of b, which is 0, squared, minus 4 times a, which is 1, times c, which is 8, all divided by 2 times my a, which is 1. And then I can actually calculate some things here. Well, negative 0 is just 0, so I end up with plus or minus the square root of 0 squared is 0, and then we have minus 4 times 1 times, and that should have been a negative 8 there, minus 4 times 1 times negative 8, that will be a plus 32, all divided by 2. Well, that looks a little bit different, but if we break that down into our pieces, we get the square root of 32 divided by 2. If I put that into my calculator, x will approximately be equal to, the square root of 32 is a 5.656854249, and then I hit my divide by 2 on the calculator. And look at that, it's equal to 2.83. Now again, there's some radical rules that I could teach you here, but you're going to learn those in grade 11, so we'll just go with the decimal form for that. But that's really equivalent to the square root of 8. Our other option then, of course, is the x being equal to negative square root of 32 divided by 2, which would approximately be equal to negative 2.83. Okay, so let's try the next one. The next one does factor. We know that in factors, negative 2 and negative 5 would add to negative 7, but they would also multiply to 10. So my answer should be x equal 2 and x equals 5. We know that already. However, I'm going to show you that even though it would factor, the quadratic formula would work. It's more work. So if you recognize it will factor, sometimes that's a lot quicker. All right, so my a is 1, my b is negative 7, and my c is 10. So my x equals negative b, so it's going to be negative 7, plus or minus the square root of b, which is negative 7, all squared, minus 4 times the a, which is 1, times the c, which is 10, all divided by 2 times a, which is 1. All right, so if I have a negative 7, that really is just positive 7, so x equals 7, plus or minus the square root of 7 squared is 49, and then 49 take away 4 times 1 times 10 is 40. 49 take away 10. I will actually write that in. 49 take away 10. All divided by a 2. So our x will equal the 7 plus or minus the square root of, that'll equal 9. 49 minus 10 is 9, divided by 2. So my x will equal 7 plus or minus, the square root of 9 is actually 3, all divided by 2. Now I'm going to break this down into the two pieces. That means x would equal 7 plus 3 divided by 2, which is 10 divided by 2, which equals 5, or x is equal to 7 take away 3, which would be 4, and then 4 divided by 2 is 2. So those were the two answers I had predicted for that one. Quadratic formula works, but you can see it's more work than it would have been had we just factored it. Same with part A. Quadratic formula works. It's just more work for this one than it would have been just to isolate. All right, moving on to examples C and D. All right, before we can actually use our A, B, and C here, we need to rearrange this so that we have our 2x squared plus x. It's equal to 3, so I'm going to subtract 3 from both sides, and we get subtract 3 equals 0. So we first have to get it equal to 0. My A value is positive 2, my B is positive 1, and my C is negative 3. And then we're going to use our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And then you do the calculation. So you have negative 1 plus or minus. I'm going to have a 1. Oh, I missed my negative again on my c value. I'm having a problem with my negatives. So the c was negative 3. We're going to have, under the square root sign, we have a 1 squared is 1, minus 4 times 2 times minus 3, so that will be a plus. 4 times 2 is 8, 8 times 3 is 24. All over 4, negative 1, plus or minus the square root of 25 divided by 4. This would have factored as well had I tried. X will equal negative 1 plus, this, or minus, the square root of 25 is 5, all divided by 4. So x equals negative 1 plus 5 divided by 4, which would equal 4 divided by 4, which is 1. So x equals 1 is one solution. Or we have x equals negative 1 minus 5, all divided by 4. That's going to be negative 6 over 4 or negative 3 over 2 in lowest terms. All right, why don't you try the next one? Put this on pause, flip the iPad or phone over, and then you can check it afterwards. Okay, so we need to get the 0 on one side, and that means I would have 6x squared minus 25x plus 14 equaling 0. My a value is 6. My b value is negative 25. My c value is 14, positive 14 there. X equals negative b, so negative negative 25, plus or minus the square root of b, negative 25, squared minus 4 times a, which is 6, times c, which is 14, all divided by 2 times a, 2 times 6. So we have 25 plus or minus. Now I'm going to do this in one calculation. 25 squared is 625 minus 4 times 6 times 14. I get 289 there. This one should factor as well. All divided by, all divided by 12. Okay, and I believe the square root of 289 is 17. Yep. X equals 25 plus or minus 17, all divided by 12. So that gives me two answers. X will equal 25 plus 17, and then that answer gets divided by 12. So 17 plus 25, that's a 42. 42 divided by 12 is 3 1/2 or 7 halves. All right, or x equals 25 minus 17, all divided by 2. 25, take away 17, that's 8. 8 divided by 2 is 4. So there are our two answers. And again, that would have factored. I would have been able to do that with factoring. There are times when factoring it won't work. So quadratic formulas are our next best go-to. So your turn is to solve the following quadratic equations to 2 decimal places. You can always verify your solution by graphing the related quadratic functions. So you could put, for example, a, let me just write this down here. For a, you could put y equals x squared minus 4x minus 8 into Desmos, and wherever those x-intercepts are, they should match your answers that you're getting with the quadratic formula for solving.